hydroelectric energy. The main components of hydroelectric energy are the dam, the turbine, the generator, the transmission cables. How does hydroelectric plant works? First, the dam raises the water level of the river to produce falling water and control the weight of falling water. Second, when the water falls, the force of falling water causes the turbine to spin. Third, the generator connected to the turbine by shafts and gears will also spin. The generator converts mechanical energy, we say gravitational potential energy of the water, to electrical energy finally. And the transmission cables transmit electricity to users. Note that the amount of electricity produced depends on two factors. First, the height that the water falls, that is h. Second, the mass of water force per second, that is m/t. The energy conversion process in generating hydroelectric powers is from gravitational potential energy of the water changed to kinetic energy of the water and changed to kinetic energy of the turbine, finally converted to electrical energy by using the generator. The loss in gravitational potential energy of the water equal to mgh, and the weight of loss in potential energy is equal to m/t gh. If the end-use energy efficiency is N, then we have electrical power generated P output will be equal to N times weight of loss of potential energy, that is N times m/t gh. The advantage of using hydroelectric energies are it is renewable and it is clean or low greenhouse gases are emitted. However, there are disadvantages of using hydroelectric energy. One of these is it will damage the environment or it damage the ecology. Also, the running cost of a hydroelectric power plant is high. Also, the efficiency of producing hydroelectric energy is low, which is about 50% or even smaller. Example 1. Part A, the energy changes is from potential energy of water to kinetic energy of water, and then to kinetic energy of the turbines, and finally convert to electrical energy. Part B, the loss of gravitational potential energy in 1 second is equal to mgh over t, which is equal to 10 to the power 4 times 9.81 times 80, which is equal to 7.85 times 10 to the power 6 watt. For part C, the output power of the turbine equal to efficiency times the input power, which is equal to 7.85 times 10 to the power 6. Therefore, output power equal to 0.65 times 7.85 times 10 to the power 6 equal to 5.10 times 10 to the power 6 watt. Wind energy. The wind turbine will capture the energy of moving air and convert it to electricity. How does a wind turbine works? First, when the wind passes over the base, the resulting pressure difference between the upper and lower surface will create a force which turns the rotor. Next, when the blades turn, the kinetic energy of the wind is converted to electrical energy by the generators inside the rotor, and the electrical energy is transmitted through the shaft to the electrical station. Then, electric current passes to underground cables to a substation where it is converted to high voltage and then delivered to users. How much power is generated by wind turbine? Net density of air below length of a blade is L. Consider a wind blows to the right with constant speed V on the blades of the rotor that swept a circular area A. The volume of air passing through the blade in time t is equal to AVT. Hence, the volume of air passing through the blade per second is equal to AV. Therefore, the mass of air passing through the blades per second, m over t, would be equal to rho times AV. Assume that the air would stop after passing through the brace. Then all the kinetic energy of the air is transferred to the turbine. Then the maximum power generated by the wind turbine is equal to the rate of loss of kinetic energy of the air. Therefore, the maximum power output is equal to half mv squared over T, which is equal to half. M over T is equal to rho AV. Therefore, we have half rho AV times V squared, which is equal to half rho AV to the power 3. If the efficiency of converting the kinetic energy of air to electrical energy is N, then the output power of the wind turbine would be equal to half N rho AV cube. This formula is very important. Note that for a wind turbine, the output power is proportional to the cube of the speed, or proportional to V to the power 3. And the area swept by the wind equal to A, which is equal to pi L squared, where L is the length of the brace. That means a longer brace has a larger area swept. The advantage of using wind energy it is renewable and clean. That means low greenhouse gases is produced. However, there are disadvantages of using wind energy. First, wind farm occupies a large area, so it is inadequate to be used in densely populated areas, such as in Hong Kong. Therefore, wind farms are usually built on high mountains or in the sea. Second, wind farm produce sound pollution. Next, the wind energy or the wind speed is usually unsteady. Also, efficiency of wind turbine is generally low. That is about 40%. Example 2. Part A. The maximum power generated by the windmill equal to half rho AV cube equal to half times 1.2 times pi 20 squared times 15 to the power cube, which is equal to 2.55 times 10 to the power 6 watt. The assumption is that the wind stops after passing through the wind turbine. Part B. The efficiency of the windmill N equal to useful output electrical power over the input, which is equal to 2.55 times 10 to the power 6. Therefore, we have N equal to 1.2 times 10 to the power 6 over 2.55 times 10 to the power 6 times 100%, which is equal to 47%.